Hi, welcome back to a new day. Yesterday the content was a mixture of data analysis with pandas and REST APIs. So we worked on data analysis and we served the data through the API. Today we're going to continue working on the API we've been building, the weather data API, and we're going to code some advanced aspects of our API. So please don't miss this day, because as you learn advanced concepts, new things also come out, and it's very important to learn new concepts in real-world applications. So get ready and I'll see you in the next video. Hey, in this video you'll learn how to go from this homepage to this. So this one has this table here with the data. It shows the station ID and the name of the station. So by having that, the users now know what ID a station has, so they can query the data accordingly by entering the ID like 3, 4, 10 after the v1 parts in the URL. So let's do that. Currently our app looks like this, so that's the homepage. And that's our code. So the home page is controlled by the home function. So when the users enter the home page URL, this home function is executed and the home function renders the home.html document, which is inside templates, and it looks like this. So how do we display that table in here? Now there are different ways to do that. But the most Pythonic way is to go to main.py, get the data frame from the stations.txt file. You see that those are the data we want to display on the home page. So the station name and the station ID. So we want to read this stations.txt file, and then we want to somehow send it to the home.html template. So that data frame has to be sent somewhere here. Let me show you how we can do that. Let's create a variable here and say variable is equal to hello there, right? It's a string. How do we send this variable to the home.html page? Well, you can do it like this. Let's say data. This is a new variable. It can be anything. I'm just saying data. Data is equal to variable. Now we go to home.html and let me split it to the right so we see both worlds. And then anywhere inside the body tags, you want to do something like this. So make a paragraph first, and inside the paragraph you have to create double curly brackets. This is a special syntax, and inside here you write the name of the variable that you declared here in the render template method. So now the value hello there will go from the variable to the variable data, and data will send that value in here. So let's go to the home page to see how this changes. Yeah, so hello there is here. So now we can try the same thing with the data frame. So instead of having the variable here, we say my or stations is equal to pd.read csv. So that would be data underscore small stations.txt, and skip rows will be equal to, so we have to skip certain rows. As you can see in stations, these are metadata, so there's 17 rows we need to skip. So go to main, skip row 17. Now let's try, instead of the variable here, we say stations, that variable. Let's see what will happen. Go and refresh the page. So we see some data. So that's the station ID for Vakwa and Falun, etc. So this is not ideal, I should say. We should figure out a better way to do this. And let me show you that better way first in the Python console here. So let's say we have stations is equal to that. So first import pandas as pd. So that's what we have. Station says a data frame, right? And now this is being printed out in here. But if you do stations .to underscore HTML, a method, what you get is you get structured HTML code. So you see we have these TD HTML tags, so these create a table, like TR stands for table row, etc. So where I'm trying to get to is that you can say here stations dot to HTML. So now the data variable will be equal to that HTML. So that HTML will be stored as a string in this data variable. Let's see now, save, and let's refresh here. So still we're not there yet. So the data look like raw HTML. That is because by default the template engine of Flask does not render HTML data as HTML. It renders them as plain strings. If you want to allow the template engine to render data as HTML, you have to write a vertical bar here and then the save keyword. Save this home.html file, go here, refresh, and there we go. So there we have the entire table rendered correctly. And if you think that this cn colon and let colon and long colon and height columns are unnecessary here, then what we could do is we could update the data frame here and say the current data frame stations, we only want a particular list of columns here, which would be stat ID and stan name. Stat ID does not have spaces, but stan name has a lot of spaces, so make sure to copy the entire length of the column, or you could also delete these spaces in the text file in here and then provide stan name without spaces, so it's up to you. I'm just going to provide the entire stan name column like that, and we also wanted stat ID, so these two should be divided by comma, stat ID and stan name, and these two are inside these brackets, and then we have outer brackets as well. Save, refresh, and now we have this. So stat ID, stan name, and that concludes this video. So let's commit the changes. We change the home.html page and main.py. So this is day 31. Show station table on the home page. Commit, and thanks for following. See you in the next video. Hi, in this video you'll learn how to add more URL endpoints to your API. So currently we only have one pattern, this one here. So that means the user queries for a particular station for a particular day to get the temperature for that particular query. Now we also want to allow the user to get all the historical data for one particular station. So for example, if they entered this URL, they should get all the data for that station for all the years. Plus, we will also allow the user to just enter the year here, for example, 1900, and they should get all the data for that particular year only. So these two things, data for all the years for one particular station and data for 1 year for one particular station. Let's begin. So let's start with the first scenario. We want to show the data for one particular station, all the data. As you know, in our data folder, we have all the stations. So for example, if the user enters the station with ID 10, we want to give them all these data from the first row to the very last row, somewhere at the end. For that, we need another function here in Flask, another URL pattern, another function. So let's say at app.root, this time the URL pattern will be /API/v1/station in brackets. And that's it. Define, let's call this function all data. The function name should be different from the other functions, so be aware of that. And station is the variable name. It doesn't matter if this is the same variable name with that, because these are local variables, so this has a scope only inside this function, and this will have a scope inside this function. So the user enters the station in here, we get the station in this variable, and then we create a file name just like we did previously here. Then we load the data into a data frame, skipping the first 20 rows, parse the date column as date, so treat it as a date format. And we don't want to extract the temperature as we did previously. We want to give the users the entire data. But how do we give them the entire data? Normally we should return either a dictionary or a list. So these are the two standards of returning data via a REST API. So what we could do is, we could say the result is equal to df.toDict. So the data frame has a method called toDict, and this converts the data frame into a dictionary. Let's see what the dictionary looks like. So let's return result, this variable, and I'm going to update the home page. In here I want to add one more URL example. You can duplicate a line in PyCharm by putting the cursor over that line and then press Ctrl D or Command D. So I'll duplicate this line, and I want to write here something like that. So this is URL example for one station for all dates, for one station for one date, and just remove the URL example part, so like that. So I'm just updating the documentation, and let's go back to the home page. So that's the documentation, and let's try this URL now to see if our app will handle it correctly. So that's the dictionary we get. Now the format of this dictionary might not be what we want. So this is a dictionary, and that's the first key of the dictionary, and that's the value of that first key. So the value of this key is a dictionary, and this dictionary contains all the dates. So that's the first key, and then we have somewhere we should have the TG key, Wait, it should be somewhere down below. So there we have the other key, TG, and here we have all the temperatures for all the dates. If you want to change the format of this dictionary, then you want to go back to your code, and inside to dict, you want to say orient is equal to records. So this will change how the dictionary is structured. So let's go back to refresh the page. And I think this is much better. So what we've got now is one list of multiple dictionaries, each dictionary representing one row of the data frame. So these are the data for the first date, 1st of January 1756. The temperature was minus 8.7. Then we have 2nd of January 1756. Temperature was minus 9.2. A bit colder. And yeah, that's it. So I believe you agree with me that this format is more appropriate for how our data are structured. So that was the first function. Secondly, then, what we want to add also is the capability for users to query only the year. For example, let's say something like this. Instead of the entire date, if they query the year 1988, then we want to give the users all the data for that particular year. How can we do that? Of course, by adding another function, app.root. So this time it will be something like this, perhaps. Or should we replace this with year and have here like define yearly, perhaps, and then have station here and year? But this is the same pattern with that one. So these two patterns would clash with each other. Because our script, our Python script, simply expects a value here, right? It doesn't matter whether the name is date or year. The script expects a value after the slash, and that value is just a value. It doesn't matter if it's 1988 or if it is 1988-25-10. So we need to think smarter here and add a subdirectory after vn and say something like year or annual, whatever you like. But whatever you write here, you should document it in the home page. So let me duplicate this, and let's say for one station, for 1 year. And that would be this URL. After v1 we say year, so the user should enter the year. So this is not the year actually, the year will be entered in here. So perhaps let's make it yearly to make it more clear that this is the actual variable actually. So for example 1988. So let's make this also yearly. So that's just part of the static part of the URL, right? These two are the dynamic parts. So we get the station and the year in these two variables, and then we create a file name as usually. We get the data frame loaded. Then the result will be equal to df square brackets, and here goes the condition, right? So the condition would be that the df date column dot str starts with so the date column should start with that year that the user enters. So it should start with 1988, for example. But 1988 will be an integer, so we need to convert it to string here, because this method expects a string, so convert it into a string. And let's print it out for now, just to see them in the command line before we render them on our API page. And let's go and make a query with the year. So let's go to the home page first, and this is what we should query. So place that in here, query it, and this is what we've got. It's an attribute error. We can only use .str with string values. So str is being used in here. You can also see the code, the error in here in line 34. So that's line 34. So str can be used on a column which has string values, but date has been changed into a date time type by this code. So perhaps we should remove that so that pandas reads the date column as a simple string column. So in other words, these will be read as they are. Let's try it again. We should have another error this time. So still we get this because this time the date column is read as a number. So let's convert the date column into a string. To do that, you say df. So the date column should be updated, and it should be equal to the current date column as type in parentheses str. So that will convert all those numbers into a string. So the df column, the date column now will have string types as values. Then save the script, go back, refresh. And we do get this error now because the view function did not return a valid response, since we only want that printed out. We don't have a return statement for now, but let's look at the command line. So these are the data we returned. We can see that the data frame starts from year 1988, so 1st of January 1988 until 31st of December 1988. So our query here is working. This query here. So we filtered out only those strings which start with 1988, the year that the user enters. But we need to convert this data frame into a dictionary using that toDict method. So this data frame now should be returned when the user enters this URL. So let's save this, refresh, and yeah, that's the date column. And if we want the other format, we should say orient is equal to records. Refresh, and yeah, this is better now. So that's the first dictionary, the first row from 1st of January 1988, 2nd of January, 3rd of January, and so on until the end of the data. That's the final code. So that's how we add more URL patterns as part of our API. So let's commit the changes. Add URL endpoint for yearly and all data, and commit. That's it. Thanks for following. See you. Hey, welcome to today's exercise. In this exercise, you will be doing data analysis. Now, yesterday you learned about data analysis, but today you'll be consolidating that knowledge by doing things yourself. So let me give you the exact tasks you have to do for this exercise. first task is to please go to the lecture resources and download the wines.csv file from there. And before I go to the next task, let me explain you what this dataset contains. So I've opened it in a spreadsheet program, and these data are about wine tastings. So let's take the first row. What happened here is that a person named Karin tasted the wine with title Nicosia 2013 Vulca Bianco Etna, and they gave a review, so they left 87 points after tasting this wine. They also left a description. The wine has also a name. It comes from Italy, and then we have the price. The price is missing for this particular row, so some values are missing, empty, that's fine. And other wines have a price, so the price for that bottle of wine, the province where the wine comes from, the region, and yeah, those are the data, and some other data here which we don't really need. So each row represents a tasting of a particular wine, and we have the data for that. Now, your tasks will be to, as I told you, get this CSV file, place it in a folder, and then open Jupyter, and then you need to answer a few questions about those data. So you'll be doing data analysis, but what data analysis is that it is a process to turn data into information. So currently these are simply data. I mean, we cannot tell what's going on here. That's why we use data analysis to answer a few questions, so to give us more information, a better overview of those data. So the first thing you need to do is, of course, to load the data frame in a variable. Then the first question you need to answer, or in other words, the first information you need to get from these data, is to find out how many wines have been given a rating of 100 points. So I showed you that we have this points column here, and the ratings range from 0 to 100. So the highest is 100, and you need to find out how many wines have been given a rating of 100 points. So you need to answer that question by using Python. The next question is, what is the name of the most expensive wine? So the name column is here, this one here. So you should make a query to find out what is the name of the wine that has the highest value in the price column. The next question is to calculate a new column where you show the ratings in scale from 0 to 5, and float values are allowed in this column. So you can have 0.1, for example, 2.3, etc. So in other words, what you need to do is you need to add a new column in your data frame, and that column will have the ratings. You can name it ratings, for example, and the column will have the ratings, but in a scale from 0 to 5. So this has a scale of 0 to 100, so you will convert this basically into a scale from 0 to 5. Yeah, I hope that's clear. The next question is to create a price histogram for wines that cost less than 100. So don't create a histogram for all the wines, because you have some outliers, data which are prices which are extremely big, and they will not create a good histogram. So you need to only create a histogram for a smaller range. So in this case, you need to create the histogram only for the wines that cost less than 100. And the last question is to plot the price horizontally against the points vertically. So X is price, points is vertically. So price, this one, points, this one. The purpose of this is to find out if there is some relationship between price and the points. So that helps us as data analysts to answer the question of, is the ratings increasing as the price increases? So your task here is to just produce the plot and then you can just think of an opinion, what do you think, if there is a relationship or not. But the main idea is to produce a plot using the plot method. And here is a tip. Inside the plot method, you can pass a kind equal to scatter argument to get a plot of points instead of lines. A scatter plot better represents relationships, and a line plot represents a trend across time. Yeah, so those are the tasks you have for this exercise. In the next video, I'll show you my code solution. See you there. Hey, welcome back. I'm excited to show you my code solutions for the questions I asked you in the previous video. So the first one was to load the data frame. That's quite straightforward. So we import pandas, we read the data frame simply as this, and I printed out the data frame just to see the data in here, to have them handy. The next question was to find out how many wines have been given a rating of 100 points. And this is what I did. So let me explain you the expression inside those parentheses first. So we use df.lock, and inside lock we have the condition. The condition is that the points column should be equal to 100. So that will give us a data frame with only those wines. But since I only need the number of them, I can apply the len function. So this is a Python built-in function. We have been using this with lists to find out the number of items a list has, or with strings as well. So you can also use this with data frames. So that's something new perhaps. And the next question is, what is the name of the most expensive wine? So I applied this query which we learned in the previous day when we analyzed the temperature data. So basically I'm finding out if the price is equal to the maximum price, and when that's the case, give me the name of that particular row. And we use squeeze to get only the name. Without squeeze, we get a series. So with squeeze we extract only the name. That's the name of the most expensive wine. The next query was to calculate a new column where you show the ratings in a scale from 0 to 5. And I don't know how you did this, perhaps you used a different formula, but I simply divided them by 20. And so this is what I got. So the rate, that's how I named this column. And yeah, we have different ratings in that scale. If you use another formula, that's fine. Perhaps my formula is not the best. Anyway, the idea was to understand how to calculate a column, to practice that skill. Next is create a price histogram for wines that cost less than 100. So I apply the hist method, but I didn't apply it to the entire price column, but I used lock, and inside lock I had a condition that the price should be less than 100. So that should give me a data frame object containing only the rows which have a price of less than 100, and then I get only the price column out of the data frame, and then I apply the hist method to that price column to get the actual histogram here. That's how I did that. And lastly, plot the price horizontally against points vertically. That's how I did this. So X contains a price, the horizontal axis contains a price. So we have a price of 0, 500, 1000. And we see that there is actually a trend that as the price increases, so do the ratings, the points. Now, does that mean that highly priced wines are better and therefore they get highest ratings? Or is it that the tasters know that the price is higher, so they tend to feel that that wine is better and give a higher rating? To understand that, we should have known if the tasters knew the price of the wine before giving a rating. That would answer the question. Anyway, that's another topic. So that's about this exercise. Thanks for following. I'll see you later.